As you see, Christoph Holz is already preparing his presentation about visalyze. His visualizations convince clients like Swarovski, Red Bull, and more. The Austrian Ministry of Science, Research and Economy granted him the Global Born Champion Award. He will start at 2. I'll give you an overview for this afternoon. At 3:30, Hugo Pinto will talk about how to cope with the challenges of public safety ICT. He's Global Solutions Marketing Director with ZTE Corporation. As a Global Solutions Marketing Director, he's engaged worldwide in sharing the successes and visions of ZTE about smart city solutions. Hugo is based in Portugal but works directly for GE, headquartered in the Enterprise Solution Department, consulting and innovation solution team. Public safety and how to take care of that by ICT. I'm very curious about that. At 3 o'clock, Sascha Pfeiffer will talk about synchronized security. Time for a change in paradigms in the IT security. As the information security industry matures, we have to accept that there is no such thing as perfect prevention, Sascha argues. Up to now, we assemble best-of-breed network and endpoint components to provide some reasonable measure of defense in depth. But we need a game changer. Synchronized security is enabling meaningful and contextual exchange of information. That'll be at 3 o'clock with Sascha Pfeiffer. Then at 3:30, Roland J. Bob will talk about secure, private, next-generation email. Over-the-top email with frictionless end-to-end encryption. So finally you know how to tell your secrets to your business partner and not to the world and your competitors. I'm very proud of having Roland Bob on this stage because he is extremely experienced. He has a broad senior global corporate and operating experience in premier telecom software, financial and technology service organizations. Mr. Bob was recently appointed President and CEO of Securecom Mobile Inc. He is an experienced global telecom professional and was previously Chairman, President and CEO of Deutsche Telekom Americas and an Executive Vice President with Mannesmann. Mr. Bob has considerable telecommunications experiences in Europe, North America and Asia. As Chairman, President and CEO of the Americas for Deutsche Telekom, he was responsible for all Deutsche Telekom activities in North and Latin America, including the alliance with France Telecom and Sprint. Top that kind of experience. At 4, Professor Dr. Isabel M. Welpe, Professor for Strategy and Organization, Technical University of Munich, will talk about business models in the digital economy. The talk will present the study Business Models in the Digital Economy, mandated by the Commission of Experts for Research and Innovation. The study assesses the status quo of Germany's performance compared with the USA, the Republic of Korea, and Sweden. Based on the results, scenarios of the future and main areas for policy action in the digital economy are derived. That is Professor Welpe at 4 o'clock. And then Jens Bothmer will talk about the megatrend design thinking. He founded the consulting enterprise Authenticity just recently this year, focusing on innovation process, business modeling, and broad brand positioning. Before, he was the director of the digital agency Iconstorm from 2004 to 2016. Before that, he was with Bertelsmann in Gütersloh. That'll be at the end of this afternoon. I repeat a highlight, 3:30, Roland Bob, our most senior and experienced participant. Sascha Pfeiffer about synchronized security at 3 o'clock. Hugo Pinto about how to cope with challenges of public safety at 2:30. And now, please welcome Christoph Holz. I like his topic so much. Survival skills for the data-driven society. How can citizen data science as a cultural technique put us back in charge of our own digital footprint? Please welcome Christoph Holz.
So, what is that? I'm going to tell you in a few seconds. I'm talking today about survival skills for the information age. Things are going to change, and we are part of this change. And I find it very interesting to explore what's going to change. What's information technology doing with humanity? And especially if we are driven by data now, how can we become the driver again? These are refugees at the northern coast of Africa searching for a cell connection. Why shouldn't refugees have cell phones? Communication has become, global communication has become a basic human need. And as John Culkin said, we become what we behold. We shape our tools, and then our tools shape us. But how? What will happen? Is the internet making us stupid or more intelligent? The only sensible answer to this question is yes, both of it. And if I watch my 5-year-old son talking to my mobile phone, he does not have one, it won't be long, I fear. If he's talking to Siri, while he still cannot write, I'm very sure he's never getting the practice to write on his own. Why should he? Even you and me might remember at the end of the year when our hand begins to hurt because we have to sign this many Christmas cards and we did not do handwriting for a very long time. So that's going down the drain. Is this sad? No, of course not. I'm still scientifically interested in handwriting. It's a very interesting topic, but all handwriting is ancient handwriting. So it's a part of history. Will it just go away, or will there be new things to replace it? Will there be new cultural techniques for the information age? How was information storage done in the early days? You might know that Australian Aborigines store geographical information in their songs. The songs they teach to their children, like saying, go to this tree and then right, and then 500 steps, and over the hill you will find some water. That's basic information storage. And of course, information in a language shapes how we think. But there's another way to think, which is somewhat more related to this drawing. It's visual thinking. And that's a thinking style that's much, much older than language itself. It exists for hundreds of thousands of years, and maybe this is a way to comprehend information and to stay in charge of our own big data footprint. Visual thinking at least equals creativity. So let's have a look. Are you a visual thinker? Who remembers faces more easy than names? Okay, very good. You're at the right place here. Who is perfect in packing his car or suitcase, but still has a messy desk? Messy desk, anyone? Everyone, I believe. So Albert Einstein said about a chaotic desk, he said, if the chaotic desk is a sign of a chaotic mind, which sign is an empty desk? Are you good in orientation in a new place? If you go to a new town to find your car, very easy, but are you bad in algebra? So that's visual thinking. The other way would be verbal, linear thinking. These are people who are usually on time because their life is very well organized on the timeline. Visual thinkers, three-dimensional, the other three dimensions, that's the competence. To explain you the video I showed you in the beginning, I would like to make an example with this. What is this? Anyone? Beg your pardon? The Hobbit, the Lord of the Ring, to be exactly, so. Which part? Come on, don't you go to cinema anymore? It's part 3, The Return of the King. A hint might be Denethor, who is part of part 3. And what you see here, I don't know if this really is going to work, no. You see Gandalf in the middle, the wizard. Why is he big? He talks a lot. And this is a conversation visualization of the script of the movie. Gandalf talks a lot, and Frodo, who is the main actor, talks a lot. Gandalf travels with Pippin, so they talk a lot, and Aragorn as well. They are closely connected. It's a gravitational force that draws people together who talk to each other a lot. And Frodo and Sam are traveling together and are talking to Gollum as well. And even to the ring, if you can see the small text. So that's how a conversation you do every day looks in a visual way. And the video I showed you, that's on Twitter. It's from a boot camp. You can see down there the participants of this boot camp in Vienna. And you see Walter Raffelsberger and Max Kossack, and you see them as images up there. So we don't have images of Gandalf, but we have images on Twitter, of course. And you see they are connected by their topic, which is, in this case, megaflop. So I don't know what it was exactly about, but that's the hashtag that connected them. I believe that's rather intuitive. It's an intuitive way to understand your data set. Below that is the so-called network effect. What I showed you is a network, and if you only have one telephone, it's really no use because you only have 0 connections. If you have 2 telephones or 2 connections in your network, 2 nodes in your network, you have 1 connection, still not very powerful. But if you only increase it to 6 nodes, you already have 15 connections. And this increases a kind of exponential, the exponential curve. It's almost exponential, not completely, and we all read about exponential economy. But what is this going to be, and how is information driving it? So the number of connections increases very fast, while you don't need so many nodes. So another node more than doubles the possible connections. But networks are usually not symmetrically, like in the example before. They are unevenly distributed, like homes, for example. And while big networks allow you massive information access, like the internet does, to travel these networks, and you might see the orange arrows, to find the best way to travel the network, for example, the shortest distance, That is a very difficult problem. It's mathematics at the limits of computation. There is no mathematical solution for the shortest path. If you really have a big network, there is no way, maybe with the quantum computer, but there is no way to find the best solution. So we get an advantage, but we buy a very big disadvantage. This exponential curve has interesting influence on our human development. So on the left side, you see 1 billion, 2 billion people. Now on the top, we have 7 billion people. It all started with agriculture. After the invention of agriculture, we had overflow. Before that, resources were scarce. But then we had enough to start arts, to start mechanics, to start science and all these things. And you see the population grew rather fast until Black Death. Some of you might remember the plague. You see the bump after that. So it's not completely exponential, but after that, especially the steam engine, this introduced the age of humanity. We are now living in the human age, and we brought the man to the moon. We invited the PC and had a lot of other inventions which actually were possible because of the overflow of more than we needed to even have more children. So, of course, this cannot go infinite if we don't go to space maybe, but otherwise the resource is limited. But the underlying curve is the curve of knowledge doubling. Until the 19th century, human knowledge doubled every century. After the Second World War, it only took another 25 years to double the human knowledge. And now, it's 13 months. Every 3 minutes, a new medical innovation, a new medical discovery, for example. So medical knowledge is even growing faster, 8 months doubling time. Other knowledges are not so fast, so the medium would be 2 in 13 months. And we are expected soon to have a knowledge doubling every day. Isn't that knowledge society? How should we grasp this knowledge anymore? How should we understand what's really going on? So, and isn't there an end? So you see the curve? It stops at the top. So it always looks like, and that's an illusion, it looks like it's finished up there. But that's just a drawing. You can stuff it into a smaller place, even smaller and smaller. It's still the same mathematical property. It's the same curve. You cannot list all the lines and everything, but that's the same curve. And if you look at it like this, you see there's a lot of space still remaining for another knowledge to grow. And maybe there is no real limitation to the growth of knowledge, at least if we look into quantum physics, which will provide us the quantum computer. Anton Zeilinger, a countryman of mine from Austria, he said, knowledge is or might be more fundamental than reality. He means energy, he means physics, he means the material world. So the material world might be a result of information. And if you look too closer to truth, you'll find the information, you'll find very interesting talk describing how much information you need to recreate the universe. It's 10 to the potence of 128. It's a really big number, but it's just a number. And of course, you would need to store this information, which is a good message for IBM. They sell all this storage thingies. But information seems to be unlimited. But what's with our human capacity to process this information? Shall we do it like Google and create Skynet? You know, from the Terminator movies, they're building it in London right now. every data scientist who is available on Earth gets an offering from Google to go there and to build this new big super computer who will have a knowledge learning curve which is exponentially. This means if he once reaches the human capacity, the next time it will be doubled, and then 8 times, and then thousands of times. So that's what Stephen Hawking fears, that's what Elon Musk fears. They invest in this too, to keep it under control. So I don't believe in this. If there would be a supercomputer millions of times more intelligent than us, we would not even see it, I believe. And at least if there were Terminators, there will be, as we all know, good Terminators from Austria as well. So, what's this big data thing? And what does it have to do with data, with Star Trek? It's about going where no one has gone before, to the limits, always pushing it to the limits. What was big data for our grandparents is small data for us now, and what will be small data for our children, they will have, and what's big data now will be small data for our children. So this is always pushing the boundaries. Of course, as you might have seen, a lot of companies invested in big data, they lost almost half of their value on the stock exchange. Why? They just could not deliver. What is the benefit of big data? What really? So Susan Edlinger says big data enables bad decisions just more quickly, more efficiently, and with greater impact. There might be still bad decisions, and I still believe we shouldn't. Decisions are much too important to leave them to computers. Big data is not only about volume, you know this, not only about speed, and not only about completely different data formats who are incompatible, it's about veracity. Is the data true? Of course you can lie with data. And the veracity problem, that's why all conventional classical analytics approaches, they just fail. Because with conventional data, you created your own data in your company, you did research, you know the quality of your data. Then you can calculate statistically, you can do KPIs and silly things like this. But with big data, even dashboards won't work anymore. The value in big data itself, as I believe, is in understanding the causality who created it. Causality is the basis for human understanding, and you need to get to this information, and you only get it on a data level. So, what I propose to understand big data, and especially to act on big data, it's understanding it in a visual way. I propose visual metaphors like maps. You already know maps. If you remember, it was quite difficult to learn what a map is, but now you intuitively can interpret them. Planetary systems, gravitational forces, and I showed you the example before. Even sound waves. I'm going to show you a Facebook example later. 300,000 people talking on Facebook, that's what they say. So what would it be if you could really see the sound wave of the people talking on Facebook? And of course, you need to act on the data. And that's the sin of classical analytics. It makes a gap between an analysis and action. So you do strategy, you analyze the last 3 years, and then you do the strategy for the next 2 years. It all goes back to illumination when Galileo Galilei said, measure what's measurable. He did not say, make measurable what is not so. That's just attributed to him. And Galileo Galilei may sure have been a narcissistic prick, and even the judgment of him, everyone in the scientific community now agrees it was right to judge him, and his judgment was too light. But he would never have said, measure what's not measurable, because that's really Silly, but that's what economics does right now. Any economists here? Okay, very well. Finally, thank you. You are the problem. Let me show you. Joseph Schumpeter, another countryman of mine, invented this. He came up with the creative disruption, but as well he said economics has to use the scientific method to become, or as I would like to say, to fake an exact science. As I like to say, if astrology models still provide better predictions than economics, this might not really be a science. The main problem are the KPIs, like CeBIT, like communication, fan interaction rate on Facebook, you name it. They even created a subprime crisis. What was the subprime crisis? It was taking financial constructs, wrapping it with a KPI, like a performance, and then wrapping it again with a KPI again and wrapping it again. The problem were not really the KPIs, it was the belief system behind it. You believed in KPIs, but what would a turnaround of a company ever tell you? If one company makes this and the other company makes this, what's the difference? How to change? So metrics can never be actionable. Or as Mark Twain put it, lies, damned lies and statistics, and if he would have known it, it would be key performance indicators as well. Why is that exactly? Can I argue this? So Mariah Mayer from TED says, statistics are stripping away much of the riches of the original data. How is this done? So if you take data points, like the points down there, and you do a statistical calculation and you finally might arrive on a KPI which you think would be actionable, like an EBIT or a interaction rate or whatever performance indicators you would create, then you would like to act on it. You can't act on a KPI, you only can act on your data. So you would need to reverse this calculation, but statistics as a mathematical property has long forgotten where the data came from. So it's irreversible, and I propose, why don't we now stay on the data level? We now have the engines for it, we have the algorithms for it, we can do it. We don't need, like 100 years ago, to boil down vast numbers to some simple numbers. We don't need that anymore. Let's take an air traffic control officer. Give him, and who of you flew in here by plane? So you know there is an air traffic control officer in charge of you, and maybe he has a metric of 230 planes in your airspace and 200 miles per hour medium velocity. What would he do with this information? So all planes would crash. He needs to see every plane, every speed, remaining flight time, height, and so on. And then something wonderful happens. If he has to land your plane, he does not need to look at the screen anymore. He already has a mental model in his mind of his data and intuitively can do the right decisions and land your plane safely. What's a mental model? Another countryman of mine, Ludwig Wittgenstein, came up with the idea that we have images of reality in our mind and we act on them. That's how you intuitively drive your car. If you come to a crossing, you just know what to do, after some time at least. So these mental models, they are predictive. They allow you to understand what your fellow drivers are doing, and they explain what is going on. So understanding and interaction. Finally, the synthesis of analysis and action as well. So how to create useful mental models? In medicine, for example, okay, your pulse is important, but it's just a metric. If your doctor wants to operate, he really needs to look inside, and that's a data visualization. That's not reality. That's the reflections of sound waves in your body. It's not a real thing. but it still helps the doctor. These are Swiss doctors mentally walking through their operation before that. And I believe you want your doctor who operates on you to have the right mental model of you in his mind. So it's based on intuition. Intuition is not voodoo. If you believe Daniel Kahneman from the Nobel laureate, he says intuition is when experts, so if you have some experience, recognize familiar elements and then act appropriately. That's how a fireman, experienced fireman, leaves the building just at the moment it bursts down behind him, usually having a greenhorn on his neck, dragging him out as well, because he did not recognize the sound pattern of imploding house. There's an intensive care medic and intensive care medic and a radiologist. Who would you believe has more intuition? It's the intensive care medic, because he has daily feedback to his information, while the radiologist only gets feedback if he sees the death certificate of someone 3 years later, maybe. So, I'm just going to show you an example of a Facebook page, because they are very complex and you cannot really see inside. So, if you did not have such a animation, and I'm going just walking through this. This is Tesla, and people are talking about model, but sorry, I have to just take BMW because I found something very cool. Ugly, that's dark, so people don't like it. And that's the Facebook posting about it. It's a new model, and people really say they hate this posting. And who is talking to this posting? I'm just showing you. This is the posting again, which is rather disconnected from the normal Facebook conversations of people like this person. Big circle means he talks a lot, but he's just a chatterbox. Much more important is this person, Mohammed, because he got 39 reactions out of his own network. And finally, that's the sound wave. Here you see this rather big posting which oversounds everything else, but BMW has another posting which is rather successful as well. And there are optical patterns. For example, with this, you can see that BMW spent some money on pushing this posting, because it's rather evenly, the sound wave is rather evenly over some time. And usually if you ask a Facebook experienced person how long would a posting survive, they would say maybe 2 hours, but as I show you here, it's several days. So to wrap up, to give it some conclusion, explorative data analysis, I think that's what's going to come, because it provides you with the answers, with the questions, and then with the answers. We use images because it's 90% of our sensory input. We can make sense of images rather quickly. Half of our brain power goes into visual processing, but there's a drawback, sorry. This was one too quick. Who sees the dolphins? Dolphins, anyone? Now you see the dolphins? Okay, so that's optical illusions. They happen with data visualizations. In this case, it just means you have a healthy sex life. If you didn't see the dolphins, some of you did, I'm very sorry. So, what's going to be the next big thing? A mass market killer app for data-driven society, and Gartner gives us a hint. They say advanced analytics with self-service delivery. One? Okay. Okay. So my second last slide, self-service citizen data science will be the next big thing, because it empowers you as a domain expert to do your own analysis at time without the need of an expert. So what we do is reintroducing intuition and action into data analysis for you, for citizen data scientists. Visit us at Scale 11 at booth D3, so hall 11, and thank you very much.
Thank you very much, Christoph Holz. It's been very inspiring as every time.